The electrostatic potential existing in space is given as AXY plus YZ plus ZX. The question is asking write the dimensional formula of A, find the expression for the electric field. If A is 10 SI units, then find the magnitude of electric field at 1, 1, 1. So this is the question that is put up over here. So for this particular question, we say that V is measured in volt. So we can say that the unit for A will become volt per meter square. So if it becomes volt per meter square, so I can express the dimension in terms of work done per unit charge. So that is ml square t to the power minus 2 upon it or at into L square. So we get the dimensional formula for A as m t to the power minus 3 I to the power minus 1. So this is the dimensional formula for A. The next question is asking for the value of electric field. So the value of electric field can be written as E equals minus dV by dx I cap minus dV by dy j cap minus dV by dz k cap. So we have the expression for potential over here as AXY plus YZ plus ZX. So if we differentiate the value with respect to X, then with respect to Y, and then with respect to Z, and fix the value of I cap, J cap, and K cap, we obtain something like, if we differentiate with respect to X, we will left with Y and Z over here. Similarly, when we differentiate with respect to Y, we are left with X and Z. So we can clearly write this equation as minus A, which is treated as common, Y plus Z I cap then with respect to Y, so we are getting A, so we are differentiating with respect to Y, we get X plus Z J cap, and then when we are with respect to Z, we are getting A X plus Y K cap. And we are taking the negative common, so we get something like this for this particular problem. Now we just need to put the value in the second part. Over here the question is asking find the magnitude of electric field at 1, 1, 1. So if I add 1 plus 1, it will become 2. 2 into 10 is becoming 20. So for the C part, I can write as that electric field expression or the electric field equation will become minus 20 I cap minus 20 j cap minus 20 k cap, and if we are only calculating the magnitude, then we can write it as root over 20 square plus 20 square plus 20 square, or we can write it as 20 root 3 Newton per Coulomb, and on solving we approximately obtain 35 Newton per Coulomb for this particular problem.